So now what we're going to do is we're going to have a look at a series of equations, linear equations, and we're going to see exactly how many solutions they have now. We can have either another scenario where we've got our two graphs have one solution, where they intersect once, where they have no solutions, or where they have an infinite number of solutions. I haven't drawn that one quite well, but you get the idea. So if they've got one solution, well, then they will have different gradients. M1 does not equal M2. If they have the same, if they don't have a solution, so they never intersect, well then M1 equals M2, but their y-intercepts don't equal. And now for the third one, the gradients are the same. So if they have an infinite number of solutions, so they're always in the same place, the gradients are the same and the y-intercepts are the same. So that's what we're looking for. So first thing we want to do with our two equations is we want to rewrite these in the form of y equals mx plus c, because then that allows us to find the gradient and also the y-intercept. So that's what we've got to do here. So let's do that for the first equation. We'll do that first. So we've got negative. And in the book, it gives us m. I'm not using m because m is used for gradient. I'm rewriting it as k. So let's have a look at this. So we've got 2x plus ky equals 1. So we rewrite this as ky equals 1 plus 2x. And from there we divide by k. So we've got y equals 1 over k. That should be a plus. Plus k over 2x. So from there we can see that our gradient m equals k over 2. Now we do the same thing with the next one. We rewrite that. So we've got k plus 3 times x equal minus 2y equals negative 2k. So we're going to rewrite that. So we've got y. So we've got 2y, negative 2y equals negative 2k minus k plus 3 times x. Divide everything by negative 2. So we've got y equals k minus, plus k plus 3 over 2x. So from there, the gradient is there. M equals k plus 3 over 2. So now we've got our equations written in the correct form. What we want to do, we want to equate k. So we want to equate these gradients because then that'll tell us where the gradients are the same. And then using that information, we can go off and find a whole bunch of other stuff. So we're going to look at this and this. So we're going to let them equal each other. So m1, m2, and we're going to say that k over 2 equals k plus 3 over 2. I'm a little bit worried I may have made a mistake here. We'll see how it goes. So multiply everything by 2. We've got k equals k plus 3. Yeah, this isn't going to work. And we're going to take the subtract k from both sides. No, it doesn't work. I've got to check my solutions. Now, silly me. If we divide by k, then this should be 2 on k, not k on 2. So I'm going to cross that out. That is 2 over kx. Sorry. 2 over kx. So therefore the gradient is k over 2. So now that's what we're going to let equal each other. So, so we've got, we're in k over 2 again. 2 over k. That's our gradient. So 2 over k equals k plus 3 over 2. Multiply both sides by 2 and by k, and we end up with 4 equals k squared plus 3k. That should be a squared. So then we'll let that equal 0. And so we end up with k squared plus 3k minus 4. And then we find 2, and then we would factorise that to k minus 1, k plus 4. So, and that equals 0. So therefore, k equals 1 or k equals negative 4. So that's what we've got there, and I'm going to stop there. We spent 5 minutes on this already, just in terms of working out and fixing my mistakes, but that's what we're looking for. So this is what we're interested in: k equals 1 and k equals 4, and we'll finish it off in the next video.